Hello everyone, my name is Adil. I'm a second year computer science student. Today I will present you my Physics 101 experiment. This experiment's aim is to see how the surface area and the angle of the inclined plane affect static and kinetic friction. In this experiment we will observe the change in friction force in different cases, such as different inclined plane angles and different surface areas of the objects. We will observe both kinetic and static friction to see the difference between them. To achieve this, the force of friction will be measured with a dynamometer with 6 different incline levels of an inclined plane. The experiment also aims to calculate coefficient of friction force, both static and kinetic, with each new incline level. Gravitational acceleration will be considered as 9.8 meter over second square. Required equipments are dynamometer, an inclined plane, and a wooden block. For the first part of the experiment, I calculate static friction force by dragging the dynamometer just enough to move. After the object starts moving, I drag the dynamometer with constant velocity so that I can calculate kinetic friction. For the second part, I do the same steps with different surface area. I repeat this process for 6 different angles throughout the experiment. These are results and graphs for both parts of the experiment. I think the experiment was successful. Force of friction decreased as the angle of the inclined plane increased, as I expected. Also, surface area didn't really affect the results. The results were almost identical for two surface areas, as seen in the graphs. There might be a few errors during the experiment. The errors for the first part may be dragging objects with acceleration rather than constant velocity, causing inertia and inaccurate results. For the second part, it can have the same error, and also the object may have different materials on each surface area that I haven't noticed. Also, the accuracy on the dynamometer may a little bit off, but overall the experiment was successful.